Okay, so now we should be recording. So welcome YouTube people. We had some technical issues, so we will have to bear with us with the audio. But okay, so yeah, because the Yeti is not giving me any audio at all. So I did update Windows yesterday or something, so it probably killed something in the system. I'm sorry about that, but we will carry on. Okay, so welcome everybody. We still got 39 viewers, so I think we just lost 2 people there, so that's okay. Man, it's just updating drivers. I have no. That might have been what actually caused it, the fact that I updated Windows. So, okay. Well, for those of you that saw the intro, that's an old game called Movie Battles that is, I think, still alive, and it's a game that I hold dear to my heart because I used to play it when I was a kid, and for a little bit of time, I actually helped to code it. And since our assignment is gaming related, I thought I'd show you that. So, cool connection. And so, anyways, let's go ahead and actually get started before we get another Buffalo Wild Wing ad. Oh, that's right. Hold on a second. I have to restart the iPad screen. Since I restarted the computer, everything, I had to shut down everything. So, yeah. Okay, we should be good now. There we go. Okay, so I'm gonna also boot up while this goes on the virtual machine because I want to show you a little bit of what I have with the game. Obviously, some of the stuff is not working right now, but I'll do my best. Okay. How much extra do you get for the attendance thing? Yeah, so that's not actually something that I was going to apply for now. That's for the 135 students in summer. So you got scam out of your 2,000 points basically. So GG. Yeah. Okay. So refund me. Sorry, no refunds. Get scammed. I don't know. I actually can refund you, I think, but I will deal with that later. There you go. Okay. Given 1 extra comment plus assignment 12. Yeah, we could do that, but then I forget and it'd be much more effort. So, okay, so here's how today's going to go. I'm gonna talk to you about the final. We'll do like a pseudo worksheet that other guy was talking about. And then from there, I will end the YouTube lecture and then we will stay on Twitch and then we can go over the midterm 2, which you should have gotten the grade for yesterday or today. And then after, I will end the Twitch stream, and then I'll hop on Discord so that you can ask me questions about errors and the grading. And I already saw some people on Discord mention with the computing the grandchildren nodes from the tree that they had it right and the TA got it wrong. So we'll go over all of that. Okay? So it just feels weird that the audio is, the audio should be good. The audio is good, right? You guys can hear me and everything, right? It's not like super bad, I hope. I don't know how bad the microphone is from the Logitech webcam. So, anyways, okay, this is up and running. YouTube lecture, do I mean Twitch lecture? No, I upload a copy of all Twitch lectures to YouTube so the students that are not here can see it afterwards. So, interesting. Okay. We have some upload issues, I guess. All right. So let me go ahead and turn this off. See pulsing. I don't know what pulsing is. Okay. So before, oh snap, what is this? Oh, this, it's nothing important of the code. So this is assignment 12, and I wanted to start talking about assignment 12 because I want to make sure that you guys are on top of that. And I did have, but again, it got closed, the PDF open so that I could talk about it, but I had to restart the computer, which didn't help. Actually, it did in a way, because at least the other microphone started working. So let's actually go ahead and start out with that. So this is your assignment 12. This PDF has been posted for quite a while now. I did update it a few times until the final version, which was posted, I think, yesterday or the day before. I can't remember when it was. Sunday? Yeah, Sunday. I think it's Sunday, like 2 a.m. or 6 a.m. or something like that. And so the assignment is you're coding CSGO basically. And so that's pretty much it. You're coding CSGO in 2D and minus a couple of features like the economy of the weapons and all of that. So last lecture we talked about it, but I just wanted to briefly go over the PDF so that you know what you're jumping into. And more importantly, that you jump into it now, because I don't want you to run out of time, and I'm not going to give extensions because at the end of the end of it, you know. So yeah, okay. So first, I go ahead and introduce what CS:GO is, and like if you don't know CS:GO, Counter-Strike Global Offensive, or any of those game modes like Search and Destroy or Valorant. Even MB2 movie battles, the games you saw and before the stream started, had a mode like this with planting a bomb in a map that was actually Dust 2 many years ago. Nobody plays that version anymore, but there was a bomb planting thing in that. You're already 30 hours on homework 2. I do believe there's about 2 people that are almost done, maybe 3. I can't remember if there was a third person. But the first 3 people to finish assignment 12 get a free Raspberry Pi as a reward and a CS t-shirt. So get on that so that you can get your, I think they're the really old ones, but at least it's a Raspberry Pi. And then you can play assignment 12 in your own Raspberry Pi. Now, disclaimer, you will get those whenever I can actually go to UNLV and you can go to UNLV and get them, right? Until the social distancing ends. But worst case scenario, I can try to sneak into UNLV, get the Raspberry Pis, and then mail them to you. But I promise I will not forget to give them to you. The one I got from last semester was 2nd generation, hella old. Yeah, well, those are the ones that you're going to be getting, so feels bad. But hey, I use one of those as a VPN still, and it works great for that. It's been up for years now, and it doesn't go down, and it works. I have it in Mexico, actually, in the house in Mexico, and it still runs a VPN. So yeah, it's quite reliable. So I wouldn't just throw it away or discard it. Linster's one of the people that won an assignment in last semester in 202, like the Inception assignment, by finishing it first in his section. So well done for that. Okay, so this time around, is it per section? So at this time I decided just the first 3 people to turn it in are going to be getting the Raspberry Pi, because after all we've combined the sections, and it will be. I know this is the whole like Senate versus Congress kind of thing, you know, people versus sections, but I think we'll just go with first 3 people to turn it in general, of all sections together, okay? So all 3 sections. So it is possible that if 3 people in section 1 turn it in, those are going to be the winners, okay? And I might give some extra awards in the form of t-shirts, because those we have a lot of, and I can just throw them around. All you need to submit assignment 12 with a file that only has your name. No, you have to actually do the assignment. So, okay. So I go over what CSGO is and the differences between CSGO when you're supposed to do. So I talk all about that. I give you an example of what it should look like when you're running it. Or actually, sorry, what the input file looks like, which again kind of looks like the game itself. A key of the different characters. This is what you want to do if you want to do the extra credit, which is to create maps for the game. If you're going to make maps for the game, they have to follow this template so they work in the game. You are allowed to submit up to 8 of them per person, up to 400 points, 50 each. If you do submit it, first check with me to make sure that you're following the QR quality control here, and then I'll not only will you submit it to Canvas, but I will upload it so that people can download it and try it out on their games, and it'll help everybody in testing their AI. So I then talk about the real Dust 2, since that's the map that I made. And then I talk about the user input and how you control the game, which is WASD or arrow keys, space to fire, and Q to quit, and I to idle. Idle is because unless you do a synchronous input, which is optional, the game doesn't run unless you run. The example people gave me with that was a super hot VR. And so it works the same way. And so because of that, if you just want to stay still but you want the game to keep going, you can press the I key and basically the game will go on without you having to move. So that's what the I is for. Of course, you can use LN curses to make the input a lot easier. You are allowed to use other input types, but support from me will end there because, frankly, I mean, PD curses and Coney.h should work like LN curses. Historically, I believe that's been the case, but you're on your own there. Do the maps have to be specifically from CSGO? No, they can be from any game that has the same game mode. So that plant bombing scenario where you have an attacker team and a defender team. The games that do that are examples are Call of Duty, Valorant, CSGO, and some other games like Movie Battles has that as well. What other games? There's a couple. I'm sure Halo had this sort of game mode. I don't know. Rainbow Six? Yeah, Rainbow Six is actually a really good example. Yeah. I forgot about Rainbow Six, actually. I don't remember. Team Fortress 2 is similar to CSGO in a way, but I can't remember. There was hats. I remember that. I actually, small story. I was at I won't tell you where. I was somewhere, and I was talking with a Valve employee, and he was, I didn't play Team Fortress or things like that, and but we were talking about games since he was a Valve employee, so we could talk about and coding and stuff, and it was me and a couple of people, and then at the end of it, he had these cards that said Steam on them, and they look like a gift card, or I guess nowadays like a Steam, like the ones you buy and you put money on them, and at the end before we left, he's like, here, take one of these. And I was like, what is this? And he said, it's just like a hat for Team Fortress or something, or a special hat or something. And I was like, okay. And I went home, and it wasn't just me, it was two other of my friends, I think. And we all went home, and I didn't care. I left it like somewhere in my office or whatever. And my friend called me at like midnight or something, or texted me or something. He's like, did you try putting the code in? And I was like, no. And I put it in. And then I put it in, and they gave me, and I think I might have like one Steam game at the time. And it was a Steam Friends and Family code, and they gave me all of the Steam games for free. All of the Valve games, correction, because that would be a lot of Steam games. All of the Valve games. And actually, when Half-Life Alyx came out, I got it for free because I had that thing there. So I think I'm forever going to get all Valve games for free. So that's pretty cool. Shout outs to that employee. He's a cool guy, but he trolled me in a good way, and my friends, But there you go. So that's all I know about Team Fortress hats. So, anyways, back to this. I can't find my mouse. So after I talk about the LN curses libraries, one whole free game a decade. Yeah, pretty much one free game a decade. Hey, but at the time I had no games. I that's how I actually got CSGO and played it, because I got that, and Portable as well. Yeah. I bet you could make a random map generator. You could, but would the maps be good? That would be a tricky assignment to do within itself. So I talk about LN curses, and I give you the brief overview of that, and then eventually I talk about a couple of things that you have to do. So even though you were coding CSGO in a way, we're really coding as a game engine, and within the game engine there's different primary aspects. And in normal video game engines, you have like a physics engine, and you have AI stuff, and then you have potentially like rendering and things. And so really what's happening here is we're coding three things. We're coding an AI, we're coding ballistic simulator, which is not really ballistics. All you're doing is shooting little projectiles, and they just go on forever until they hit a wall. And then you're coding the game itself, so that you can render it and things like that. And so I go ahead and I split those three topics and talk about each of them in order. Here I'm talking about the ballistic stuff and all the logic behind that. And I go into a little aside about, is that where I talk about that here? Well, I guess I might have gone a little bit too fast. I don't know, what page am I on? 7. Yeah, I'm talking about ballistics here, I think, yeah. And then I go ahead and I talk about AI, so the AI side of it. This is the pathfinding part where you're going to implement Dijkstras. And then this is important. This section here tells you all the logic you need to know to code the AI, of like the decision tree that the AI has to make to decide where it's going to move and when it's going to shoot. So the AI within a certain tick of the game can move a single spot in the map, which you can think of a 2D grid. It can move a single spot, or usually it moves, but it doesn't always shoot. For shooting, it has to see if there's anybody in its line of sight, and then if that's the case, then it'll shoot. And then you do this in the loop for all the AIs, And then when you finish, that's one tick of the game. And then you do it all over again in the next tick. And in between ticks, you also check projectiles that are being shot, because they got to move one tick as well. And then you render the game. But before you want to check user input as well. So yeah, the main is very small, and I have it in here. So this is the logic of the AI. And then I go, and this is where you can stop reading if you just want to know what you need to do. However, some people ask me for a detailed explanation of how to do things because they didn't know where to start. So I went ahead and I put in about 10 pages worth, more than 10 pages, like 12 pages worth of a summary of my implementation, so that if you get stuck on a specific part of the implementation, you can refer to the documentation here and get some tips about that. Or you can read it all and basically copy what I did. But the choice is yours on how you want to do that. And so my implementation, what I did is I had the code open, and as I went line by line, I took the important things and I threw them in here. The ordering of my classes and things like that, that's how I put it here. Most of the variables that I used are here. Obviously, I've been tweaking the code every day, so this is a little bit outdated, but it's minor things. And I also skipped some irrelevant things as well to include here that I found necessary. And I go all the way from the top with my includes, and then I talk about the classes. So like I'm talking about the car map class, which is the one that reads in the map for the input file. The entity class, which is the super class that all the other entities derive from, which is what you gotta declare at first. Then I go into talking a little bit about movement. I don't remember why I went into movement at this point, even though I wrote this like 2 days ago, but I did. Because it might be because I was going to talk about movement in terms of entities, and I wanted to clarify. The biggest thing that I want to point to everybody out who's never coded anything like this before is the way that we're rendering it is we're just printing into the terminal. And because of that, and let me see if I can get this right from what the camera you're looking at, the first piece of text that you would print out is here. And then you print, and then go to the next line and move on like this. Because of that, you can think of this spot here as coordinate 0, which is exactly what I have on the picture there, right here. So even though I have x and y coordinates, they're not going to work like your normal graph this way. They're going to work as if they're twisted downwards. Okay. All right. So moving on from entities, we have some derived classes, which are the bomb class, projectiles are entities too, and of course we have the players as well. I go into an aside about talking about a little issue that you might run into with the projectiles shooting yourself, because they spawn basically where you are. And so I have a little aside from that might be interesting for you to read, which is where this is coming from and how rendering causes problems with games and stuff like that. Player T. Player T is going to be the player class, and it's also coming from entity class, so they're all child classes, derived classes, whatever you want to call them. And I talk about some of the functions, like an important being rip, which is the function that runs when the player gets killed. Point T is the class that is basically made up of that makes up the map, and all the entities live in these points. It's a 2D array of points, and each of them has an ent list, which maintains which is a vector, which maintains pointers or references to all of your entities that are currently in that spot. And then those move around basically. So you delete the pointer or reference from this entity list and you put it in the next entity list on the next point over on the left, right, up or down, right? Which you can use that thing I wrote earlier about how to go up or down, which because of the way the graph is, when you're increasing your x value, you actually go down. When you decrease it, you go up. However, for the y values, if you increase it, you go what you would think is, which is going, how are you looking at this? You're going this, even though I'm holding this hand, don't look at the hand, you're going right if you increase it. And if you decrease it, you go left, okay? I'm looking at the webcam, so I have to do it backwards because the webcam makes me think it's a mirror, but it's not. Row major and column major doesn't really have much to do with this, so don't get confused with that. By the way, again, you don't have to follow any of the stuff that I did. You could do your own thing as you wanted. I'm just saying this is one way to do it, which is the way that I did it, because it just was, what felt right at the time. So I talk about that class. I talk about level class, which maintains that 2D array of pointers, literally of point class. And technically, it's a 3D. It's a 2D array of pointers, but you can see here the 3 asterisks because it's a 2D array of pointers, which each pointer could potentially hold a lot of things, which if you were just thinking of an array, it's like kind of like a three-dimensional array, but it's not, because it just holds a pointer, which happens to have other things as well. We're using OOP. If you did the Battle Royale assignment with me in 202, we're not doing it that way because that made us happen to like a 4D array, which was so. Anyways, these are all the functions from that. Then I talk about the ballistics dispatcher, which is your ballistic engine stuff, and then the AI dispatcher, and then the movement dispatcher, which is just not really a dispatcher. It's just three functions that I decided to put in the class together because it's object-oriented programming, and so it just felt more contained. So those are the ones that actually read the keyboard input and then call the second function, which actually makes the move. And then the third function does post-move checks, which handles things like, did I just move into where the bomb is? If so, pick it up by automatically. That kind of things. And then the AI can actually call the move function as well. Not the re-input function, but the move function, so that they can move as well. So the AI really has the same control you have in terms of keyboard input in a way. So they both call the same functions, which is kind of cool. This is the class descriptions for the AI. And then this is my main. I went ahead and posted it like this, but I also posted a picture of it, which is this. And I'm going to talk about it. As you can see, it's a very, very tiny main, as it should be if you're doing things right. In fact, I could make this even smaller, but I chose to leave it like that so that it was a little bit verbose to help out. I don't think I have changed the main since I made this document, basically. But I did put the picture there. And then that's it. Some memes, closing notes, which you should read. So this page you should read. After you finish, if you don't want to read my implementation, skip to this page, but do read this page because it clarifies a couple of things. And more importantly, it talks about the extra credit and about your write-up. So yeah, make sure you do your write-up as well. It's a little bit of a longer write-up, but most of yours, I was looking at assignment 11's write-ups, were already this long anyways. So mostly I want to see the mini version of this. Really, really mini version of that. And so that's it. I put a little disclaimer there so that people don't think I'm violating copyright by having CSGO images here. Okay, so that's the assignment, and hold on a second, I just lost you guys. Okay, you can tell us your pranking jokes over. No, there is no joke. Here is the running code minus the working AI, because I'm still messing with that and I had some issues earlier. So, assuming it compiles still. Welcome to the game. Pressing the key to continue. Chat, T or CT? What do you want me to pick first? Defenders or attackers? I'm waiting. Since there's probably a delay. C. Okay. That's not as fun right now, but okay. Counter-terror is selected. Okay, so if everybody knows CSGO, you know that going through mid can be a scary situation, right? So, however, because I have very slow bullet speed, the AI will shoot at me, but you know it's gonna take quite a while for it to actually get there. But I could, I could troll them. In fact, I can outrun bullets by going the same speed as the bullet right now. But let's just stay there and die, and then the game will actually keep going without me. But the AI is not gonna do anything, so they're just gonna chill there forever. Let's just restart it again to do something more interesting. Let's try to plant the bomb this time. So I can pick up the bomb. As you can see, I just picked up the bomb. Now I'm gonna go to the site. Actually, let me kill the AI first. So press space to fire. Fire a couple of times. Bullets don't collide each other, as you can see. And that's actually gonna end the game. Yeah, terrorists win. Because all the AI is standing in the same spot, so they die pretty quickly. You can shoot through, as you saw, through obstacles, and depending on the direction you are is how you shoot. You can team kill as well. I just team killed my entire team. And then let's go ahead and plant the bomb. So the AI right now is not moving, but it is still looking, and it shoots at you when you go in its line of sight, as you can see. And then 3, 2, 1, bomb exploded. There is one. And that's it. So that's something that I have right there. Bullet speed, not hit scan. Yeah, so I didn't do hit scan, but can you run to your own bullets? Right now you can't outrun them. However, I set it so that if you somehow could, you would not kill yourself. I could make it hit scan actually, because right now it's kind of kind of lame that you know, the AI like shoots pretty slow. But I want to leave it like that because it makes for some interesting gameplay. You'll see. But you can definitely change the speed of the bullets, and I think I put that in the write-up, because you know, otherwise it's just kind of going. And notice that the bullets despawn when they hit a wall. That's okay. But yeah, I can totally outrun bullets right now. Look at that. I'm outrunning the bullets right there, and then move out of the way. They can also shoot through the. Oh, I died. Oh, they got me. They must have got me when I passed right beneath them. Yeah. So I was gonna show you going under the tunnel. Let me go under the tunnel. Actually, you know what I haven't tested yet? This is actually good to test. What if I go on top of the tunnel? I think they can they shoot at me? Nope, they don't shoot at me. That's a good thing. So that's good. I went to the bridge and they didn't shoot at me. However, right now they should shoot at me. We'll see the bullets show up in a second. No, bullets are not showing up. Okay, so that is a glitch. See, I'm glad I picked that up. So right now, I guess I made them not look at all through the tunnel. That was working earlier, but yeah, so they're not, yeah, I walked into their shot. So there's a glitch. So as you can see, there's a lot of glitches that are still gotta be patched out. Let's see what people say. So the AI moves or just shoots. The AI should move. I just don't have it on right now because I was messing around with things and it's doing very weird things. So I can show you that on Thursday if you want to see the working AI. Yeah, mine is broke right now. Normally they would. Is this a synchronous input? No, right now it is not a synchronous input. It's optional. I'm probably going to add it to mine at the end, but that's going to be the last thing I do because that's a pain to debug because you're talking about multi-threading potentially. So not multiple threads, different things, but yeah. So anyways, that's it. Can we move on to the test now? Does the AI know when to you plan? It will move. It will move. It moves. Like Thursday, I'll show you with a moving AI. Before I even made a video, the AI was running into a wall. That has been fixed. Now it moves, but it's doing some weird things. And sometimes it crashes the game. So yeah, I have to fix some issues. Would TA side AI go to the same site every run using the pathfinding algorithm? No, I have it on the PDF that you randomly pick the site at the beginning. That way, some T and some T go to with the bomb to whatever site the bomb picks, but they can also do their own thing. It's just basically RNG. I didn't specify specific parameters. I usually just go with like 50-50, or every option is the same probability and so on. So, yep. Okay. Going back to the PDF. Here we go. All right. Okay, so we will talk more about that on Thursday. Is the skeleton code function released for us? Yeah, it's been released for a while. That skeleton light has been released, and then my main, the PDF has some code as well, including my main, which you can also use. But frankly, that's going to confuse you more if you don't know what's happening. You know, instead of doing your own main how you want to do it. But I did put it in there as I wanted to explain my logic. Okay, so disclaimer. We do have class next time, and we will talk about new material next time, but I wanted to do the review today so that you can focus on studying for the test and not have to wait until Thursday to do it. Okay? And hi guys, remember when we learned AI and decision trees in the class? It's just an if statement, guys. It's okay, don't worry about it. I wanted to say something. Oh yeah, that's right. Happy Revenge of the 5th, guys. That's why I'm wearing a Star Wars shirt. I got the Star Wars theme going. So, yes, that's what I wanted to say. Okay. So, let me go ahead and talk about the final exam. First of all, the final exam is this Friday. Okay? That's literally 3 days from today. From 12 to 12. Okay? So, big thing. It's a joke in case you're not aware. It's a big meme on the internet. Machine learning is just an if statement. But in our case, it's actually just if statements. We're not making like super advanced AI or like coding even in the real AI language or doing any fancy things. We're just basically hard coding a couple of decision trees on things like what to do depending on the choice. Basically, it's like 2 nested if statements and a bunch of function calls. The hard part is the pathfinding part. The hard part is like knowing where to move. So if the AA has chosen to go to the bomb site, how do you actually move it there? That's the tricky part. You can use Dijkstra for that or other things. Dijkstra is the one that I recommend because that's what the assignment is, but you can do whatever you want. Can you have additional office hours assignment 12? I mean, I've been on Discord for the most part, and very few people actually message me. And the ones that do, I help them pretty quickly if I'm awake at the time. It's a skeleton function release available to us. We already released a skeleton code last time, so that's that. There's nothing else. You're not getting more. I can, if you're really stuck somewhere, I can give you a hint based on my code solution, but there's not going to be more skeleton code. You're on your own. And we computed it, and this assignment is worth now almost the same as the Inception assignment, which is about 13% of your grade, which is in line again with 202's final project. Okay, so final exam. The other thing you have to worry about. The first thing you should know is it's not comprehensive, as we decided. And it's going to be a very algorithm-focused test, okay? You're going to have to do a couple of algorithms, which are as follows. We have depth first search, breadth first search, topological sort, from there we jump into the more complex ones, which are going to be Prim's minimum spanning tree. I think Prim has 2 M's, I can't remember. And then Krosko's minimum spanning tree. I have decided, since it's not cumulative, that I will ask a question on each of those. And then, of course, Dijkstra. Was BFS also on 2? No, it was not. As far as I know, it was not. And yeah, they're almost worth about 100,000 each, so that we can keep the meme of making it 1,000,000 points. There are going to be a couple additional questions. I suppose, I don't want to call it graph theory, because that's a whole different thing, but on graphs, okay? Which, the theoretical stuff of graphs, such as like a dense graph versus a sparse graph, and things like, you know, the definition of a graph, like, and well, I'm not gonna go and ask you that one lemma that somebody posted. I forgot the name of it. Haskell's? No, I don't remember. It's the one that even number of vertices gives you an odd number of edges, or vice versa. But there are going to be some questions like that. Okay. There are going to be still my negative questions. Handshaking lemma, thank you. See, I knew it started with an H. But ultimately, I'm hoping to keep it under 10 questions long. So here we go, 2, 4, 6, potentially there we maybe have about 2 questions there. And I have one more question that I already thought about, which I'm not going to tell you, of course, because it's going to be my trick question that I'm going to ask you, that negative questions. So yeah. But yeah, about 10 questions long. I'm actually trying to keep it shorter than the second midterm. Do we have to code? No, you do not. You do not have to code. If drawn, how much do you want us to show? The same that I showed in class. So that's why we're gonna go over some of those examples right now. Like, do we need a stable? Yes. So for these two. Sorry, I had to think for a second. It really threw me off because the microphone wasn't working. So for Krosko and Dijkstra's, you are going to have to draw your table. And my recommendation for that, if you have a smart device, is draw like one table and then refresh it like 20 times. Refresh it, copy and paste it 20 times. And that way you can show the updated values each time. If you don't, well, that's why you're giving extra time to do the test. Can you upload a PDF of the exam so I can print it and write it out? I could do it that way, or I could do it the way that I had it. And frankly, I think I like it the way that I have it online because it allows me so like when TAs grade it, they can grade it directly there, and I can get the grade of each question. So I'm going to leave it like that. You can always like print out the test probably from Canvas. You should like be able to print the web page or something if you want to do it that way. But really, there's not going to be that much. Like for example, I decided that these two, I'm going to use the same graph to avoid doing more work than I have to. And then these two, I will probably, but not 100%, use the same graph as well. So, in fact, I might even use it for all three, but I don't know yet. So, you shouldn't have that much stuff if you really want to print it out. So can we draw everything like you did in the lectures? You can draw everything if you want. I mean, there's very little writing that this test will have actually. Only these questions, like the theoretical questions, which should be relatively easy because there's not a lot with it that I really taught you guys. Oh yeah. Hold on, I might be missing one thing here. I mean, there's going to be a question on disjoint sets, but I'm not decided yet if I'm going to make it part of the prim question or not. So 2, 4, 6, 8. Yeah, so that makes it actually 10. So maybe we'll put a disjoint set question. I haven't made the test, but I have guidelines. These are my guidelines right now that I'm going to follow when I make the test. So yeah, expect a question on disjoint set. Not necessarily to do the cycle detection algorithm, but possibly in the theoretical side of it. Is the exam still max 4 hours? No, I'm probably going to bring it back to the midterm length, which is 3. I will go ahead and do the test tomorrow, probably. Or today. I don't know. First I want to fix the microphone. It really bothers me that that's not working. Dang. Okay. So, other questions before I go on and show examples? Just give the TAs enough time to take it. Oh yeah, I guess I should make the TAs take it, but I don't know. They have their own test to worry about, so I'll have to decide on that. So basically, we'll learn how to traverse to those 7 items. I don't know what you're saying with that. Can you what are you talking about? Traverse to those items? What 7 items? I have no idea what you're talking about. How much extra credit was the TRICE assignment worth? I wrote it there. I think it's 5, 10, or 15% of the final. I think it's 10%, but I'm not sure. I've written it somewhere. 61 people watching now. Yeah, but that's not the highest we've had. There's still like 70-something plus people that turn in assignment 12. We just need to learn how to use algorithms by paper. Yes. Yes. Or by paint. Not necessarily paper. Basically, the way that the TRICE assignment works is it's what it would have been if you had an extra credit question at the end of the test. But I didn't want to put it at the end of the test because we already had enough hardship trying to get the whole online test going, and I didn't want to have you to spend extra time figuring out a bonus question. I'd rather you actually spend the time getting the test done early in case you had technical issues. And I mean, most people finish in 2 hours and 55 minutes, so I don't think they would have had time for the bonus question anyways. I think you're all expecting here to 1v1 me for skeleton code or something like in 202, but the fact of the matter is that for a 300 level class, that's it. You're not getting any more out of me in terms of skeleton code. Can we have a bonus question for the final? No, you cannot. There's no extra credit for the final because we've already offered extra credit for something related. Can't remember. Probably the fact that I have a bunch of other things. So no, there will be no extra credit on the final. What are we getting a new microphone? I hope the microphone is not fully dead. But if it is, then at least it happened now and not like 3 weeks ago when we still had class for 3 weeks, I guess. The extra credit assignment is 10% of the midterm 2. Please give alternative assignment 12. Nope. Assignment 12 is decided. Is Padme a good dog? Padme is literally sitting behind me right now and sleeping. And it's actually making me very warm. You should have raised the assignment 12 as easy as the top assignment 12. That was a joke. Although, I think it's easier than the Inception assignment, but that's just me. Definitely more fun. Okay, so I don't think there's anything else that's important, so let's just go ahead and do some examples, I suppose. This is way bigger. No, it's not bigger. Plus, this is 300 level course again. The only thing is that you got spoiled because you got the skeleton code for the Inception assignment. So here you're not. You're getting, you got a skeleton code. It's not just like 99% of the solution like it was in 202. Does it have to be dynamic, or can we just print out the map every time we move? I mean, let's put it this way. The way that the implementation works right now is everything internally happens to update the game. And then I reprint it every round. But instead of reprinting it from a character map, I reprint it from a list of pointers because I can decide how to print it. If you just try to stick with all characters, you're going to run into so many headaches when you have multiple people and bullets and other things on the same coordinate point. So, I'm just saying. It's going to be horrifying. Anyways, okay, let's go ahead and go do these fast. Because you don't know how like desperate I am to try to fix the microphone. How's that for a graph? Okay, and then maybe one more node. Yeah, one more node. Okay. That's right, you do. And that's called pointers. I use an entity list of vector actually, which is my ent list in the point class. That's frankly your best bet for doing that. It's a very standard thing to do. Okay, so here we got a little bit of a graph. I'm reusing the graph for a different set of algorithms. And then maybe 8. Okay, so minimum spanning, yeah, we could do minimum spanning tree on this one too. But let's go ahead and do, and then maybe this one we can do like, oh, that's bad. Like that. Okay? So let's go ahead and do topological sort on this one. Let's start with that one, topological sort. Since I have it ready to go. Okay? So here we got a graph that has edges. How many edges do we have on this? 1, 2, 3, 4, 5, 6 edges. And this is a directed acyclic graph. Or is it? Well, I think it is. It was not acyclic for a second when I was putting the arrow here, but I fixed that. If there's cycles in the graph that you're trying to do topological sort, you're going to be stuck there doing it for a long time because you're never going to finish. Using printf is really slow. You mean print W? Because the ln curses uses print W. So that's what you want to use. The problem with using C in and C out is how you're going to get around the fact that you got to press enter after each input. It's horrible. I got to press up and then enter. It's like, that's not how real games work. So that's the only problem with C in and C out. If you can get around that, then you don't have to use ln curses. And ln curses, we discussed it when we were talking about the extra credit for the Omega watch in assignment. I think it was like 8 or something, or 6. It was before before we split out for the spring break. However, I have like 2 pages on the PDF that talk about online courses, and thank you for the link. There's a discussion there. The 2 basic things you gotta know is print W and get car. Print W is how you print to the screen. It works the same way as C's printf. Tons of documentation on that, as you might guess. And get car is how you can read a single character from the input, which can be the arrow keys or WASD. Should be quite a piece of cake to learn that. That'll be the least of your concerns in the assignment. Okay. Topological sort. We need to pick something to start that has an n degree of 0. N degree of 0 means that it has no input coming in. Of those, we have 2 of them. This one and this one. So let's go ahead and pick D. Okay, so we got D. Once we go ahead and add something to the output, what we do and what you would do is you would redraw the graph. And delete the edge. And I suppose the node might as well. From the graph. Okay? And so now, you gotta pick another edge that has an n degree of 0. E has an n degree of 1 because it has an edge. And B has an n degree of 2 because it has 2 edges coming in and 1 edge coming out, so out degree is of 1. But we don't care about the out degree, we care about the in degree. C has an n degree of 2. So really we only have one choice, which is A. Oh, you want to make me dab. Okay. And so we're gonna go ahead and take A out. Okay? And so now we're left with just E and C. We cannot, what E and C, B? You cannot do B or C because they still have an n degree. However, you can do E because it has nothing coming in. And so you would redraw the graph again. Don't put it in the same order I'm doing it unless you actually like put arrows to show the progress. And then get rid of E. Okay, next we're gonna do B and then C, because as you can see already, that's just gonna become a single node C once you delete the B. And then you're done. No cycles because you actually were able to finish. And the graph was connected. So you want to show a step in the output? Yes. So basically what I have right now here, maybe in a little cleaner fashion, so you're not going in a circle, but if you do, I guess it's okay, you know, is what I would want for this question. For topological sort. This right here. Okay? All right. Let's do BFS and DFS, which of course are depth first search and breadth first search. However, we're going to run out of space, so I'm going to zoom in to make more space. Or actually here, why don't I just move everything down a little bit. That should give us enough space. Yeah, okay. This one, it's going to take you a while because of the stack and queue that are involved in doing them. And yes, I do want to see the stack and queue. I don't want to see just the math 351 or 251, whatever class version of this, where you're just like drawing stuff one at a time. Like, oh yeah, I have this. And then I have this. And then I have, well actually, yeah. Yeah, and then the third version would be that, potentially. Like, no, I don't want to see that. That's cool that you understand the concept, but I care about your algorithm solving skills. How many partitions do you plan to put in the graph questions? Not too many, because otherwise you'll be spending there a long time. So I would say maybe, where's the other picture at? For topological sort, you can expect 5 to 6 approximately. And for the other algorithms, it depends, you know. I'll try to keep it small because of all the drawing involved. But then again, you should just be able, if you don't want to do anything on paint or anything like that, just do it on paper. Okay. So for this, which one should we do first, chat? Breadth first search or depth first search? Drawing is tedious. Tell that to Bob Ross. So, breadth first search. Okay, thank you. All right. So breadth first search, we are going to need a queue for that one. So remember, that one requires a queue and that one requires a stack. Okay, so you start out by picking a node where you're going to do the breadth first search from. So we're going to go ahead and pick A. Okay, and so what you do is that you look at all the edges that are connected or coming out of A. And in this case, we're looking at an undirected version of this graph, or unordered is another term. So we're going to go ahead and look at those three edges and see where they go, and we're going to add them to our queue as long as our visited array does not include them. So let me go ahead and put that in. A, B, C, D, E. Okay? And right now we mark them all as false. Okay? And so, wow, that was a big delay for the last person that wrote it. You gotta refresh the screen, the stream. Okay, so we got A, and we check if E, B, and C are marked as visited. They are not. Therefore, we dump them in. Doesn't matter the order. We're gonna stick with the alphabetical order. I suggest that you stick with the numerical ascending order or alphabetical ascending order in the test. While you don't have to, I think it'll make TA's life easier if they only have to look at one solution. Otherwise, they have to check whether each one works. And as you can see, that can be kind of tedious and higher room of mistake. So while it's not a requirement, I plead to you that for your own good, to avoid mistakes and things like that, go with the alphabetical order when you're adding things like this to a stack or a queue, okay? I would also say the same thing about the minimum span, about the topological sort. I didn't actually follow that here because I went for D first, but just go with the alphabetical order. And I'm going to put it in the test to remind you, but I think that way all of the answers are the same. And no, we're not going to suspect you cheating because you're all doing the same ordering. It's because I'm telling you, because it'll make it faster to grade. Do you add A to the queue? No, because that's where we start. And when we start somewhere, we already marked that as visited. So I didn't put it there because I was going to put it at the end, but you want to make sure you don't visit where you start from, so you never add it to the queue, because otherwise that would mean you go back to it. When our test 2 grades coming out, they're already out, as people are saying. Yeah, I think they were posted this morning or publicly. I guess they finished the last batch today. So okay, so we got B, C, and E on the stack. Sorry, the queue, and we finished adding everything. We're good to go. We mark it as visited. We can go ahead and move on to the next thing. At this point, we don't even have to look at the graph. We just look at the queue and dequeue the next thing. So that's going to be the B. When we dequeue it, I suppose it's a good idea to check if it's not been marked as visited before you add it to your output. In this case, it's not, so I add it to the output. Okay. From there, I see what edges are coming out of B. We got 1 to E, 1 to A, and 1 to C. We go ahead and we add those in. So let's go with the alphabetical stuff. So I suppose we can go ahead and add E and C there, or C and E. And notice they're already in the queue. You want to make it smart. You can check to see if they're in the queue and then you don't add them. However, we're doing this the dumbest, simplest way. Okay? So you add them to the queue. So for reference search and depth first search, graph weight does not matter. No, it does not. Not in the traditional format of the algorithm. It's just printing out the entire graph. Yes, you're correct. Okay, so you don't add A though to the queue because A has been marked as visited. So you don't add that to the queue. Okay, but E and C still are added because you don't know what's in the queue, unless you do, in which case you don't add them. Okay, if you know what's in the queue, you can not add them as long as they're either marked as visited or they're in the queue. You don't add them. But again, we're making the simplest version, which is why you see them in the queue. I'm just emphasizing that so that you know that. Okay. All right. That's it. There is nothing else to do with this, so we go ahead and mark B as visited, and we go ahead and dequeue the next thing, which is going to be the C. Okay, we check if it's been added to the output. If it's been visited, it hasn't, so therefore we add it to the output. And then at that point, we can go ahead and see what's connected with C. We have an A, a B, and a D. So let's go ahead and add B. Oh, no. We do not add B because B has already been marked as visited. So we do not add vertices. We do not add vertices to the queue if they haven't marked as visited. So B does not get added, and neither does A. However, D does get added because it has not been marked as visited. Okay? All right. At that point, we can consider it to be done with C. We can go ahead and dequeue the next thing, which is going to be the E. It has not been marked as visited, so we can add it to our output. And then we go ahead and see what it's connected to here. It's connected to A and B, but they are both marked as visited, so nothing gets added to the queue. Okay? Next thing, we got a C. It comes out, however, oh, and don't forget, we marked E as visited at that point. So next we get C, but here's the thing, the C has already been marked as visited, so we don't put it to the queue, we just dump it away. Okay? All right, dequeue the next thing. It's an E, but it has also been marked already as visited. So we don't add it to the output, we just throw it away. Okay, the next thing, we got the D. D has not been marked as visited, so it does get added to the output, and then you do the same thing. Okay, what's connected to D? C is connected, so let's go ahead and add it to the queue. At that point, we're done. I can't scroll down. Thing crashed. Fail. I can draw, but I can't scroll. Okay, there we go. D gets marked as visited, and then we're done with that. What is that? I don't even know what that was supposed to be. What was that? My guess is it was a C. They just thought I did a circle. So we go ahead and dequeue the C. C that is marked as visited, and we throw it away. Don't forget to mark that as visited earlier. And at that point, when the queue is empty, you can consider yourself to be done. Alternatively, when you see everything marked as visited, you can consider yourself to be done. So there's a lot of efficiency things you could have done to this. For example, checking the visited array can take some time, but you can make a hash table and you can lower that time to like O of 1, right? With the if no collisions. So you dequeue at the bottom and enqueue at the top. Yeah, I guess the way that I drew it, this was the top or front. Well, you call it top, but sometimes people call the front of the queue the top. So be careful with the terminology. Let's just call it front and back. And yes, the back was at the top of the page, but just be careful because when we think of a stack or a queue, the top is the next element that's going to come out, which in the queue is the front. So beware of using the term top and, that. So we give us a starting node, right? So I was thinking of making you pick your own node. However, again, to not have a billion different outputs, I'm just going to go ahead and make you pick, and tell you which one to pick as a starting node. That way, again, we have a limited amount of possibilities that could be as answers. I mean, hopefully there's only one answer, but there's not much I can do. You can also, so I guess I erased it, but yes, anytime you change the queue, you want to redraw it. And you don't have to make a nice little square, you can just go ahead and put it as letters. Like, I don't know, let's say that this is what's in your queue at the time, I don't know. So you can just draw that, and then next time you say that there's that left, and so on. That way you don't spend an hour trying to make your work artistic. All right. Let's go ahead and do that first search. So for this one, it's the same thing, but with a stack. So go ahead and copy our visitor array over. You don't have to redraw the visited array. You can just put a comment in your answer saying, mark this as visited, you know. We don't add to the queue if it's been visited, right? Yes, so you don't add it to the queue if it's been visited. That's why, otherwise you'd be adding things forever. Like, literally, if you had this graph, and you started from A, you add B to the queue, right? Okay, you dequeue B. At that point, you see A, so you add it to the queue. Okay, you're finished with B. Now you're at A. Okay. You see that A has already been put in the output, but B's there, so you add it to the queue. So you go back and forth forever, basically. That's why you want to mark something as visited. Viewers are going down, by the way. We got 50 now. People got class, or they're scared. Do we need to show multiple queues and stacks to show progression or not? Or will the TA guess? Do not think that the TA will guess anything, because they might guess the wrong thing. And by that I mean like against you, basically. So you want to be very explicit and show the queue, like I said. Okay. For that first search here, we're going to go ahead and start from A the same way. And so in this case, I'm going to go ahead and kind of show you a good way of doing the stack thing so that you don't have to show it 45,000 times, okay? So will you post a study guide on the web campus so we know? Nope, this is your study guide right now. So like this right here. That list there is your study guide. I forgot where I was. Here we go. Okay. So A, what do we add to the stack? E, B, C, and D. Let's go ahead and stick with the alphabetical thing I was talking about. When will the tries assignment get graded? That's a good question for the TAs. I don't know. I'm assuming pretty soon, because, you know, they have their own finals to worry about. So I think they want to get everything out of the way. Same with assignment 11. Plus that's extra credit, so, you know, it's in the low list of priorities for them to grade. Okay, so B, C, and E have been added to the stack. We can go ahead and mark A as visited. So you can say like visited A, and that's it. And then your ongoing output, which is just A. And from there, you go ahead and I was gonna say DQ, but the correct term is pop B, and add it to the output because it has not been visited yet. Okay? So when we pop B, we're gonna be adding to the stack E and C, but not A because it has already been marked as visited. Okay, see, we wrote here visited. All right, and so we can redraw our stack with the added content. So again, let's go ahead and stick with alphabetical, and we're at B, so that would be adding C and E. So C, E, plus whatever was already there, which is C and E. Okay? Again, I guess technically speaking, alphabetically, it would be EC, not CE, right? Because it's easy, just like the assignment 12. Yeah. So are you grading 12? No, the TAs are grading it, as long as they're still alive and everything. But you sure bet I'm going to be checking them out myself, because I'm very curious to see what you guys do. Just like I was looking at assignment 11's reports, which, by the way, I like some. I know some of you didn't like it, but I like the fact that you guys did all the graphs. For those of you that actually did it and didn't forget, which shame on you because you didn't read the assignment. But I like the charts. Like, I see it, and your reports just look prettier. It's not just like blobs of text, you know. There was one that I saw that didn't have the graph because they said that it was too boring. Shake my head. But they had blue font for the titles of each question or something. And just the fact that they had that was the first time I saw color in the text for all the ones that I had seen at that point, and I think for the rest of them. And just that little thing made it look so much nicer. Like, it made it look website-ish. So, you know, I was like, wow, okay. Color and graphs are a good thing. They make everything more interesting. And I think the TAs appreciate the fact that it's more interesting as well. So I might have to do that for the next semester. Just require some sort of plot or graph for every assignment. Just to make it more interesting to see. More stuff like that for the PDF. Well, I mean, it's more of like the graph that you're doing is like measuring, you know, run times and things like that, comparisons and stuff. It's not more for the PDF, for like for you guys to do. So yeah, they'll have fun in the fall. Yay! You know, I kind of want to reuse the CSGO assignment next semester because I spent so much time on it, like to make the write up and everything. So I might actually reuse that. I don't know. So don't share your code when you finish. So why is it starting with EC and not CE? Because I was putting things in alphabetical order, which means I would have seen C before E. And because it's a stack, C goes in first and then E, which makes it look like E and C. So even though CE would be correct, I'm just sticking to do it alphabetical so we don't get a billion different outputs to grade, basically. But both are correct, technically. Takes a space easier to fill out the PDF, I suppose. I mean, it's not like there's one guy that I saw that had like super huge font. I'm not kidding. It was like literally like that big. And I was like, okay. I feel like offended. Like, am I blind? Is this why you made it this big or something? If you put B first, wouldn't it pop last? Oh yeah, good point. Snap. Even though I did do it correctly there, I did not do it correctly there. So, I mean, this is correct, but if we want to stick with the alphabetical thing, I should have done ECB there. Yeah, let's go ahead and restart that then, just so you can see the exact way that I would want it alphabetically. So, this would have been ECB. Good catch there, by the way. And so then we would have popped E. And when we pop out E, we would have seen that E is connected just to A and B. So we would have added a B in here, but not an A. And we would have marked E as visited. Okay? At that point, we would pop B out. So we got A, E, and B. And then our stack would have, okay, so now that we're at B, we have E, A, and C. However, A and E have been marked as visited, so the only one that we actually add to the stack is C. So we got C, C, B. No, don't put C there yet. I got confused for a second. You just add it to the stack. You don't print it out. Okay, so CCV. And then we can mark V as visited, okay? All right, at that point, we can pop out a C. And let me go ahead and move this a little bit more down. So pop C out. So now we got A, E, B, C. And then C is connected to A, B, and D. A and B have been marked as visited, but D has not. So we can go ahead and push to the stack D. However, don't put two C's there because we already popped one out. Like such. Okay, DCB. And then we can mark C is visited. All right. Next, we're going to get that D, and D is connected to C, which has already been marked as visited. So all that's really going to happen at this point, you're going to pop D. It's going to get added to the output, at which point, not, you know, and you mark this visited D, but nothing gets pushed to the stack. So stack is still the same. Okay? So stack still has C and B. At this point, you know, we're going to pop D out, or sorry, C out, but nothing will happen since C has already been marked as visited. So you'll have to just keep going and pop B out. Nothing will happen again because B has already been marked as visited. And at that point, you're going to be done. I forgot to copy and paste, I think, my C here. There we go. So as you can see, that's your answer. Yeah, push it alphabetically. Okay. So that covers the first three algorithms here. And now we can move on to prim, cross-call, and Dijkstra's. So let's go ahead and do prims first. Or sorry, cross-calls. Which in my head, for some reason, is always known as Krusty. Like Krusty Krab. Or Krusty the Clown. I don't know why. But I always think of Krusty when I think of cross-calls. Well, I mean, it's spelled similarly, so that's probably why. But yeah, okay. So as you can see, we got the same graph, but this time it has weights into it. And so we're going to solve it, right? And so the way cross-call works is you have to sort out all the edges by weight, and then adding the edges doesn't create a cycle. And so let's go ahead and do that. So we have, I'm just going to list all the weights first, and then we'll sort them. How about that? So you have that. I'm very, very hot. I'm going to have to kick my dog out because she's making me really, really hot. Like sweating. And then CD. And I think I got all the edges. 2, 4, 6. 2, 4, 6. We have a question though. For BFS and DFS, if all the nodes are visited, can we just write something like all visited, empty stack, and all good? Yes. Instead of popping the rest and checking, yes. If the stack or queue is empty, you're finished. Yes. If the stack or queue is empty, you're finished as long as you have nothing else to. At that point, you have nothing else to do, so you're done. However, also, if everything is marked as visited, you're also done. However, you may not know, right? Like I'm showing you when I'm doing this. We're doing the baby version where like you have a list of all the nodes. But you may not have that. Like, for example, when you were doing assignment, well, you did when you were doing assignment 11. But, like, if you had a graph and you don't know, like, how many nodes there are potentially, because it's just pointers, and you're just kind of going there blindly as you're going, then you would have a list that you're creating continuously, so you'll remember where you've been, but you don't know when that list is complete. So, really, in that case, you have to just stick with the whole until I have nothing else to go, because my queue or stack is empty. That's when I know I'm done. That's kind of how we did it in Inception, actually. However, for the purposes of the test, sure, if you said that everything has been visited, you can call it a day. Instead of popping the rest, okay, so I think, yeah, okay. AB is 1 and AE is 5. Did I make a typo? AB is 1. EB is 1, Oh, yeah, this is meant to be an E. And then, what else? Oh, and I wrote EB. Yeah, the rest is fine, I think. So, thank you. Okay. Drink water. I have a lot of lights to be able to do this. Like, just so it looks okay, and it's also making it hot too. No, I think the time has come. You should go. So, bye, Padme. Go do something. Okay. So she's making me like super hot. So yeah, okay. So we got a bunch of lists here, and then we're gonna sort them by weight. So let's go ahead and do that. In the test, you can just put the sorted list at first. You don't have to show me the sort algorithm or something. That's if it was a comprehensive final, I would make this question be a dual question, like sorted using quicksort, and then also once you sorted it, run cross-calls. But you know, we're not making it cumulative, so we will assume that you run a very efficient algorithm that's not bubble sort on this. Okay, and so, all right, we've sorted the list now with our magical bubble sort algorithm, and so now we are gonna go ahead and start yanking edges from this list from top to bottom, from least to largest, and only the ones that do not create a cycle. Okay? You'd be surprised. A lot of people did not select selection sort as the slowest algorithm in the A-bit test. They picked like merge sort and heap sort, and I was like, okay, you know, I guess you can live in that world. All right. So this is the tricky part. How do you show whether something creates a cycle or not? Do you want to like go hardcore and show union disjoints and all of that, union find? And the answer is no, but I do want to have the idea of the sets. So I still want you to sort of keep track of what you have, and the best way to do that is to draw all your vertices out like this. And then as you do this, I want you to join the sets as you would, okay? And then that way you can tell me when you create a cycle. So what you will do is you're gonna go ahead and you can be verbose and say add 1 EV to minimum spanning tree, okay? At which point you can go ahead and draw B and E in a little bubble like that, okay? And then the rest of them on their own thing. So A, C, and D. You can do them like that, or you can draw them in their own little bubbles. Okay? So that's going to be the first step that you do. So we'll put it like that. Next, you're going to look at the next edge, which is AB, and in this case, you're also going to add it. So 1, AB, and you want to draw the latest version of your thing. So A, B, E, and then C and D on their own. Okay? I guess she's back. So from now on, you can go ahead and look at the next edge and just keep adding as you see there. So A and C. So add 2 or 1? 2. AC. And go ahead and draw your graph here. So A, B, C, E, and D. And then the next edge you're going to get is 3BC. So 3BC is not added. because the union, if you consider that you can label this as S1 and S2, S1 union S1, because it's not disjoint. You could also say something like A, B, C, E union A, B, C, E, or sorry, not union, my bad, apologies here, intersect, not union, sorry. Damn it, I keep wanting to put an A. So ABC union ABC ABC is not equal to the empty, okay? So the point is, you do not add that, and you let me know that that is the case. Similarly, AE, with a value, I think, of 5, yeah. Is not added. Again, put the same explanation why, that they're not disjoint. And then finally, you add 8, what is it, CD, I think, which makes one big set. So A, B, C, D, and E. At which point you're done, okay? Because you run out of edges to add. So there you go. It looks ugly, but it's honest work. It gets the job done. I'm not gonna lie, I'm kind of lost on what you're doing. If you're lost in the algorithm itself, just rewatch the video when I cover Csgo's algorithm, and then rewatch this, because I can't really go and re-explain the algorithm from scratch. If we do something like because fine is, yeah, would that be accepted? Yes, that would accept it perfectly fine. In fact, I didn't want to throw the fine and union thing because people would panic. But if you know that, that's way better. Okay, so yes, so you could, instead of like, you could do like union A, union B. You do something like that, you know. Or actually, don't you, I mean, yeah, you could do it like that. And then, you know, find, it's not equal to find B. You could say that instead as well. Okay? Yes, you do this Csgo in the exam because it's probably the easiest way with the least amount of writing to do. Oh. Yeah. Thank you. Okay. Now we can move on to prims. What happened to the other graph? Should we draw a final graph? Yeah, it might be a good idea. However, I really care about the process, not the output. But I suppose in the case that you make a typo in the process, drawing the final graph would actually help you to get partial credit. So I would draw the graph. Why not? And if you're curious what it looks like, it's basically going to be that. Okay. Why is it not equal? Because we're trying to say that the union of these two sets, which are actually the same thing. Oh yeah, when I flipped that, I should have said that. So the intercept between these two sets is not empty. So that means that there's a cycle. So if you want to be more verbose, you can say that. You can say the intercept between these two sets is not equal to null. because the union, the actual intercept of this would be actually equal to A, B, C, and E, you know. And so you want it to always be empty because that means that there's disjoint, okay? You like this way better than the tables? Yeah, but the table is a nice lead-in into Dijkstra's, as you saw. Like, it's the same algorithm, essentially. Well, yeah, but you're going to have to draw the table for Dijkstra and Prim, so you haven't gotten away with that yet. So, in fact, let's go ahead and hit our table up. Look at my perfect rectangle. So good at drawing, right? So what are the things that let's remember. So we want to have the nodes, I suppose. That's probably important. So A, B, C, D, and E. I took a perfectly drawn rectangle and I just made it horrible looking, but it's okay, guys. I think we need to have the key, the parent, and visited. I'm doing this off of memory. I don't think I'm missing anything. I think that's it, right? I think that's it, right, chat? Let's go with that. I think we're good. With verbiage, what verbiage would you use in the test so the TAs get what we mean? The verbiage that I used already. That's pretty much it. Okay, so initialize everything to infinity, with the exception of the node you're starting from, which you want to initialize to 0. Troll dog. Okay, and so parent here, there's nothing really to put there, and you want to mark it as visited because when we get done it'll be visited. So we're going to go ahead and update all the weights that are connected to A. So that would be E gets 5. Actually, here, the first iteration of that we'll leave like that. Oh, I already copied and pasted it. I actually forgot I did that. Okay. So you can go ahead and just leave it like that so that I know that you know how to initialize the algorithms table. Okay? All right. So now we're going to do all the visited stuff for A on this one. So that means that we're going to update E to... Let me copy and paste this down here so I don't have to keep scrolling back and forth. Let me put it like maybe there. Yeah, that'll help us for both. Okay? And so we're going to go ahead and update E to 5, A to B to 1, and A to C to 1, or sorry, to 2. And that's pretty much it. We got B, we got E, and we got C, yes. And of course, all the parents of those are basically A. Okay? You probably like it better when I'm using letters and numbers, because remember when we did in class numbers, it can get a little confusing between the weight and the identity of the node. So I'll try to stick with letters in the test as well. The goal is not to get you confused. That's what the negative question is for. So anyways, okay, from there we go ahead and we pick the smallest weight. The smallest weight is going to be B. So let me just very quickly, and realize that I can't copy and paste it before I do it because otherwise I have to refill the chart. I'm gonna copy and paste it after. No. Hold on. There we go. Panicked for a second. Face, I don't know what that means. Okay. So yeah. Okay. We're gonna go to B. We're gonna mark it as visited because we're about to get going on it. And then let's look. So B's got E, A, and C, right? E, A, and C. We don't want to mess with A because remember that's how we break things. So because A has already marked as visited. C is where we're at. Wait, what? Hold on a second. Got lost for a second. We're doing B. Yeah, okay. So C, we can update. And so we can update E. Either of these we can update, okay? So let's go ahead and do that. So here's the thing. With C, if you look at the algorithm, I'm not going to paste it, but the little logic that I wrote. The edge from B to C has a weight of 3 to it, okay? Or I guess I'll put the number first because that's what I was doing earlier. That means that we're comparing 3 with 2, and 2 is less than 3. So therefore, you don't update that weight on the table, okay? So that takes care of that. You don't need to show that whole decision as long as you show the latest table after you visit each vertex, okay? However, with the E, you do update it from 5 to 1 because 5 is smaller than 1, okay? So that's it. It's the second time that you draw the third time you draw the table for the second vertex that you're visiting. Okay, moving on. We've got C, D, and E. We're going to pick the lowest value, which is the E. So we're going to work with that. E is connected to A and B. However, both A and B have been marked as visited, at which point nothing happens. You're done. Okay, cool. Moving on. All right, we got C and D. C is smaller than 2 is smaller than infinity, so we go ahead and we mark that. We start working there. C goes to A, B, and D. Both A and B have been marked as visited, so the edge does not get added or compared or looked at all. However, the edge from C to D has, potential to change something, and it does. It changes the infinity here to 8. So we have found a new smaller edge coming from our source node, which is C. And so from there, that's it. That's the only update that happens. We're going to draw this one more time. And basically mark it as visited and we're done. That last drawing, you don't have to put, if you put an explanation saying that whenever you have V minus 1 vertices visited, you can stop searching because the last vertex will by default, as long as the graph is connected, not update any edges. And even if it didn't, even if it was not connected, it will still not update anything. So, yeah. Can we show the initial and final table? No, because I want to see the process of the edges being updated. As you can see, even though the initial table, which is empty, and in the final table, there's a lot of things that got replaced. So I want to see those replacements happen. Such is life. Okay. We're almost done. I'm tired. And we still got to do the whole review thing for the grades of the test too, so yeah. We got Dijkstra and disjoint sets. Disjoint sets, theoretical question, like I said, or something related to that. We kind of already talked about that, so there's nothing to say there. The graph theory stuff, there's nothing to say there. Just watch the video again. Again, things like, when is an adjacency list better than the adjacency matrix? I think I literally have asked that. I have here, even though I didn't show, I have my old final from not last semester, but the one before that. So spring of 2019. And I'm going to be using that as a reference to create those questions. In case you're curious, that final that was given on May 15th of 2019 was only worth, you can't see it because of the camera, but it was only worth 330 points. 330 points. That's really small. I was looking at that and I was like, wow, okay. Compared to like 1,000,000 points or 202's finals that had like thousands of points, this was only 330 points. And I could have made it smaller without making decimals because there's questions that are worth 5 points each. It was still 25 questions long, so it was still a big test. 29 pages long. But, things change. I guess I gotta pull back on the big numbers for the stuff. But yeah, see, I have a disjoint set question from here. I have an entire page of graph theory questions. I might use some of these again. I don't know. This baits it a little bit. The question says, and here's a good question that I'm not going to use, but that is disjoint set related. It says, given the following two sets, are they disjoint? Why? What is the union of them? Is the union disjoint? And so, to answer that question, since I kind of briefly reviewed disjoint sets, the two sets that I was showing here are set 1, which is FORTNINE, and then set 2, which is PUBNG. So that's actually the final exam question. And so I ask, are they disjoint? And the answer is yes, they are, because they don't share any letters in common, right? Yes. Is that what? Yeah. I have a here, but you know, I don't trust my own solution because I mean this is a year old, so you never know. But yes, they are indeed disjoint. What is the union of them? The union of them would literally be me just like taking this, putting it here, taking this, and putting it here. And do notice something. I clearly was trying to make a reference to Fortnite. However, I cannot have a T here because things have to be unique in these sets. Should have asked that as part of the question, actually. Is the union disjoint? Of course it's not. Because once you union it, you know, if you were to compare the big set here with any of the smaller sets, they share everything in common. So of course the union is not disjoint between like this guy and this guy. So we got a couple of things. If the final exam is in a grade category by itself, I don't think the number of points matter. It's just going to be a percentage regardless. Yes, you are absolutely correct. It does not matter how many points the test itself is worth because it's its own category. I do believe it is 25% of your grade, which is why you're saying it's 50% of the entire test grade, I suppose. So yeah, whatever the syllabus says. So anyway, I have another question on disjoint sets in here. What does this one say? That's easy. But I'm not going to talk about it because I might actually use that one in the test. Who knows? Hey, that's a good thing if it's easy, right? So as a kind of a, in case you're curious, in the cumulative version of a final, I had maybe half the questions, approximately half the questions were on subjects that were previous to the graph stuff. So really, 10 questions versus 12 questions. So you're really losing 2 questions, but it's almost like I took my old final and just literally janked out the finals, the third part of the class's questions and used it. So if this was a doable test in 2 hours, and I suppose I should make the final be a 1 hour long, but then again, it's different how, you know, different people take different times. Oh yeah, that's right. Whatever I talk on Thursday, there's a small chance that you might see 1 question on that. It's a very easy question, but I do want to put it there because it looks good to have that on the test. And so you can expect it to be there. And that'll be a little bit about the algorithm stuff that we'll talk about. Okay? So, all right. That kind of should talk about disjoint sets already for you. So really all we have left to do is Dijkstra. Yes. Review your own graph theory stuff on your own. So conceptual questions. It's kind of hard to talk about those without giving you the answer away. Where's my graph? As you can see, You can almost use the same graph for all the questions in the test. You just change the weights on it. Makes life easy to actually create the test. So I might do that. I don't know. I might not. No, probably not, because I feel like you guys will get confused for some reason. Plus, like, I want there to be relaxation steps in Dijkstra, and I don't know if there's gonna be any here. No, there's not gonna be any relaxation steps if you were to do it like that. So that's probably why we'll use different graphs. In fact, because of that, I'm gonna start with E for this example, because I want to show you the relaxation step of the algorithm in Dijkstra. And if we start with A, oh no, there will be a relaxation step here. So yeah, we can still start with A. Perfect. Okay, cool. Wow, this graph is amazing. It literally worked out for everything. Please make the final as quick as possible so we can work on 12 more. I mean, I already made the final non-cumulative, so that should help you a lot in terms of preparing. The tutoring office closes on Friday, so what? Yeah, that'd be sketchy, trying to ask the tutors for help for your final exam, and they don't know. That's very illegal to do. Can I just, I'm just gonna copy paste this guy. Okay, we're ready to run. Oh, for the final project? Well, that's okay, because you already had a week on the final project, so yeah, you could have already been done with the final project. Oh no, there will be no curve for the final. Definitely no curve. There's no curve for the midterm too. No curve for the final, and probably, not gonna lie, there's not going to be a curve for the class, actually. No, I thought there would be, but looking at the scores on the second test, there's no need. So your grade is your grade. There's too much already, extra credit and all that. No need for a curve. I'm actually surprised. I think there's maybe a total of 5 people in the entire class sections, all 3 sections, that are actually at risk of failing. And that's because they just stopped turning things in. So of course they're gonna fail. The last thing they turned in was assignment 1 or something, or even nothing. So, but people that have actually been turning in assignments and taking the tests, I don't think there's anybody that's failing. There's a couple of D grades, maybe very small amount actually, 3 or 4, but then everybody's passing. In fact, people did it's interesting. People who had low grades, D, C, and a low B, did much better on the online final, and the people that were B or A, they either maintained or slightly went down in the online final. So that's an interesting thing. That means that people were really scared and they studied harder for the online final, and they did better as a result. And the people that got a really good grade on the end class final, or the final one, didn't study as hard, or maybe just were more relaxed about it, and either had tech issues or who knows what, but they went down. So that's an interesting statistic. So the scores got squished together now for the test too. It's too much. No, assignment 12 is not too much. Drop the lowest assignment included. That's funny. But we're all here for a reason. That's to learn Trio 2. And it would be unfair to the people who have come before you in my Trio 2 to drop a grade or make the final project easy. It would make their hard work worth less if I just gave everybody an A, right? Kawa's a hardened veteran. He did a lot of these assignments and bled as he did them. And I can't just be oh yeah, all of you guys get an A, and then all his hard work has gone to the garbage, right? But yeah, test 2 people did really good. Do you know if SU counts for prerequisites? I do believe it does, which means, technically speaking, all you need to get is a 61, which I think is a D-, to pass the course, to be able to take the next class. So, yeah, there's that. I said I told you a month ago. No, 2 weeks is good enough. That's what I said I would do, and that's what I'm doing. Because it's twice the time you get for a normal assignment, so yeah. Same thing for Inception, was 2 weeks. Can we get previous 302 final projects? Of course not, because then people basically post the answers online, and then people cheat. So I have to do something different. If we get it all completely right, then we become the best 302 class ever. I will say this, it's a little bit trickier than the previous times, the final projects, but it's not that different. I mean, there was pathfinding in the previous ones. 60 to 62% is a D minus. Okay, so there you go. So 60% is the goal. And the final project is worth about 13%. So you can do the math. If you don't want to do it, you can just take a D and do the U. And, I'm sorry, the S, and you're good to go. It is worth a lot, but then again, so was the final project in 202. That's a pretty standard approach. Previous 302 final project was being way easier. Nah, it was pathfinding as well. I can pull it up sometime if you want. Yes, there is of course some people that were teaching 302 that made it too easy, which is why I'm taking over so that doesn't happen again. And they have been reprimanded for doing that, actually. So, yes, we're standardizing everything. And as you saw last semester, we standardized the final project. And this semester, all 202s have the same exact assignments. And that's basically what's going to happen in 302 as well. So, yes. All right. Anyways, let's not think about other people and let's think positive. First of all, you got 2 weeks before the end of the semester, and then you got just a couple of things on the way. You will get them done. Doesn't matter what other people do. What matters is what you do and what you learn, because you're the one that's going to eventually go and look for a job, and you want to get the job, not other people. So it's in your benefit to know more than others, because then you will have an advantage. So don't think about other people, think about you. All right? So, okay, let's go ahead and finish Dijkstra, because we still got to go over the test. And I know there's people that have issues. Oh, by the way, I never reopened Discord again after I rebooted the PC. I should open that and see if there's any questions on that. Okay. New audio device detected. Don't switch, don't switch, don't switch, don't switch. There's some glitch going. It's got to be that Windows update. And I have... Nah, I don't want to go on a rant on Windows. Oh man, there's like so many DMs, but I'm sticking to whatever's on the lecture. Okay, there's no questions on the video lecture chat. Perfect. Okay. All right. So let's go ahead and talk about Dijkstra. And as you see, it's very similar to Prims. The only difference being that you don't compare the previous key value, but you actually add to the previous key values. So we start out with the same parent, and that goes to E, to B, and to C. Okay? And right there, everything's still the same. So I could have actually copied that one instead of the first table, because it's still gonna have 1, 5, and 2 here, and the parent of all is A. Well, and by the way, this works for both Dijkstra and that's some weird glitches there. That works for both Dijkstra and Prims, but the whole backtracking idea of once you have this, how do you actually draw the minimum spanning tree? You can go forward or backwards, doesn't matter. But either way, it's just saying there's an edge from E to B that is 1. There's an edge from D to C that is 8. There's an edge from C to A, which is 2. And there's an edge from B to A, which is 1. And that's it. That's your minimum spanning tree. And if you compare that with the graph, it's gonna be what we did earlier. Where's that minimum spanning tree that we did earlier? this one right here. Should look the same. It's just going to be, it's going to visually look different, but it's still going to represent the same graph. And by the way, the reason they call it minimum spanning tree is because this looks kind of like a tree. So that's why it's called like that. So yeah, it looks pretty much the same. It just looks mirrored. So like this part is mirrored to this part, as you can see. And then we can kind of lift the E up here, and we basically got the same graph. So yeah, you just have to use your imagination to do that. Okay? All right. So now let's go ahead and continue this. So we went ahead and we updated all of the vertices going out of A. And so we can basically check A as visited. So for permanent Csgos, we have to draw the resulting MSQ from the table. That's what somebody asked earlier. You don't actually have to do that part. I would, because if you make an error, at least you have the final answer, which will get you more partial credit than if you don't have the final answer. And plus, you actually might catch yourself. Like if I had drawn this and seen that and saw something sketchy going on there, like not what I expected, then I would catch myself that I have an error. But you don't have to do that part. So I would recommend you do it, but if you're tight on time, then hey, it's not required. Okay? And so let's go ahead and move on here to the next lowest weight, which is going to be the 1 from B. Okay, so this B has edges to BC, BA, and BE. But the BA edge you don't want to look at because A hasn't marked as visited. So you're only looking at C and E. But how do you update? Okay, before I would say like, okay, well, is B to C, that 3, is it smaller than what I currently have to C? And the answer is actually no. But that's not what I'm going to look at here. What I have to look at is how much it took me to get to B, and then add that to this edge. So you actually would have to compare 1 plus 3 and compare the 4 with what's currently in C, which is 2. And then, of course, you still don't add it, okay? Another better sort of example of that is going to be from B to C, from B to E, because that's actually an edge of 1. And so what you're going to do is you're going to say is the current weight that you have to get to B, which is 1. So take that B key, add the edge from B to E, which is 1, which that's equal to 2. Is 2 less than 5? And the answer is yes, it is. So at that point, you can go ahead and put a 2 there and change the parent of that to B. Okay? And then you're done with B. The ad blocking does not stop the wings. You must have installed it wrong, because I never get ads on Twitch, like ever. What you need to do is you need to turn off low intrusive advertising or something on the settings. I'll show you later. Still sucks. You got that. Can you record the midterm 2 review? I cannot, unfortunately, because I don't want that to be on the internet. Because even though I don't use the same test, it's too much information to give to other people. It's unfair. It will be on Twitch, though, unless bad things happen again and it disappears, which no guarantees. You know, last time it was like luck of the draw. What I'll do, though, is if it does happen, at least I'll record it locally, and I'll find a way to upload it again on Twitch. That way we have a backup. Unlike last time where we didn't have a backup at all. I think it would stay on Twitch. At least for... Twitch deletes things after 14 days. So it should stay, but... Yeah, you never know. Okay, let's just get this done. I'm tired. All right, so we got 2, 2, and D. Why do we have? Oh, why do I have 2s? It's okay, I guess. But anyways, we gotta pick one. So let's just go ahead and pick C. C goes to A, B, and D. Both A and B have been marked as visited, so the only one you add is D. So you're not going to add A there. You're going to add the current value of C plus 8. So that's 10. And you mark that source as C. And that's it. Nothing else gets updated because, yeah, nothing else. They've all been marked as visited, so you're done at that point. I guess I should redraw that so you can see the multiple iterations of this, how you would do it on the test, which is the same as the prim, but you know, I want to show you anyways. So let's go ahead and put that there, and then let's go ahead and put that version here. But in this version, this was infinity, and C was not marked as visited. Yep. And then our initial one would be the same as our previous initial ones, and the second one would be the same as the second one that we did. So let me go ahead and put that one there as well. Hold on, let me move this. So that's our first one. And then our second one is actually the same as before. That's just how, I guess this is a rule per se, or I don't know what you would call it. Prim and Dijkstra on the first vertex you visit will always give you the same result. Okay? All right. And so, okay, so now we actually got everything that we needed, so we can keep going now to the next and final step, probably. And yes, the YouTube ones will stay forever on YouTube because I want people in future semesters to use them as review, in the case that they miss a class, or in general to prepare for a test and things like that, which is why I don't want to just flat out put a review in there that actually talks about the previous tests that I've done. Yeah, it's basically the same thing as prim with just more weights, which again for the first vertex will be the same. Probably monetize those videos. I cannot because I use copyrighted content with the music in some of them, so I cannot monetize videos. Plus I got demonetized in YouTube actually because they changed the requirements to like a way higher amount of subscribers. But I made like $100 on YouTube before they demonetized me. That was nice. Okay, so we're gonna go ahead and pick E because that's the lowest one. And so E, it goes to A and B, which we are gonna not do anything because A and B have already been marked as visited, so nothing happens there. That's why I said we have one more step, but nothing really happens. So then we get to D, and yet again in Dijkstra, when you have only one node less to visit, nothing should update at that point because it's impossible for anything to update because everything else has been marked as visited. So again, you can save yourself from drawing this one last picture by saying that you only have to visit V-1 vertices. And that's it. That is Dijkstra. We're done finally with review for the test. As I said, on Thursday we will have class. We will talk about material, and some of that may show up in the test in a very, very brief and non-deep way. It's probably going to be like a theoretical question, but I do want to put it in because I think it's important what we'll talk about Thursday, which is P versus NP, SAT problem, which I think I talked about in some of the sections at some point. I do remember that, but I'll talk about it again. And a little bit of the algorithm analysis and the 5 different types of algorithms that we've looked at. So that's what Thursday will be on discussion, okay? All right, so at this point, we're done with the review. And I'm going to go ahead and call it a day on class, and I will keep the stream up because I'm going to start talking about midterm 2, and we can talk about the questions. I will very briefly go over the task on Canvas by having it open. But primarily what I want is to hop on Discord and just talk to people and see what they think is wrong, and we can talk about it, okay? Stop the recording, so I'll be back in a second.